Welcome to this week's Learning with Lindsey. And on this part of the Weather Lounge show, we are going to talk about, just break down the science behind weather that's happening across the area. Now, this week is Severe Weather Preparedness Week. So what I'm doing on our Learning with Lindsey segment is going to be just breaking down some of the storms that we're going to have coming through the area, of course, ahead of severe weather season. Now, we've already had a few storms and severe threats throughout the last couple of weeks, so we're already in the severe weather season. Now, we're going to discuss obviously the typical types that we'll get in this area, but various areas across the country and the threats that go with each storm type. So first up is a derecho. This is typically just straight line wind threat. Now, we've definitely seen this before in the Mid-South, but it happens all across the country. Midwest and the Mississippi Valley are the most common areas in the summertime, but it's basically just a straight line wind threat. Now, we've talked about straight line winds. It's winds that aren't rotating and have no chance of rotating, but it's particularly for a derecho event, it is long lived and typically for, spanning hundreds of miles and typically producing very strong damaging wind gusts. So to issue a derecho event, you need 240 to 250 mile length, like time of that this derecho event has been alive pretty much, and then producing 58 mile per hour winds consistently or along most of the path. So it can die down for a minute, but if it picks back up. Now, we've seen this already before in the area. I know a couple of years ago we had a derecho event, but also I think the one that Todd Demers pointed out to me that the Mid-South is most familiar with was from Hurricane Elvis. Now, of course, this can be continuous and mostly not associated with downburst winds because it has to be so long-lived, which is why it was such a big thing with our Hurricane Elvis that came through. By the time it hit our area, of course, it's not a hurricane anymore, but it did provide still these damaging winds. Now, you can also see it. It's called a bow echo. Right through here, the way our radar just kind of bows out, it looks like a bow and arrow, and it's because these winds are rotating back in and continuing to add gusts in the center of this straight line winds. It can be insanely damaging, just as strong as any tornado. So derecho events, I mean, you can't rule them out, even though we're used to tornado warnings and that's where everyone gets the most scared. Wind threat is, again, just as damaging. All right, now head to a squall line. We've already seen several of these passing through the area. Typically, they develop along frontal boundaries, dry lines, cold fronts, and they're a long, skinny line of thunderstorms, and they are going to be severe thunderstorms typically, not necessarily across the entirety of the line, but at portions. You're mainly getting a wind threat or even spin up tornado threats because the main threat with this is those damaging straight line winds. And you could get derecho events with a squall line, especially when that, just continues to move across the entire country. Now, of course, you'll get lightning, you'll get hail as well. And we've seen this event now twice just since the season has started. Now, as we head through, they can last, weak tornadoes can pop up and they can last just, a few minutes. You're looking at EF0, EF1 tornadoes that spin up along a squall line. So it's not the main threat, but what you get when you have this squall line passing is you'll get these little areas of just quick rotation. All right, characteristics of a squall line, they're typically spanning hundreds of miles, meaning from the north to south, it can be the entire country getting that squall line, but only 10 to 20 miles wide. Again, very long, skinny line of thunderstorms. Straight line wind damage, but of course, leading edge of those storms, and I'm going to explain that in a minute how they form, but you can get those tornadoes on a leading edge, form in unstable environments and typically along or ahead of cold fronts and dry lines. That's what I said. You need a lot of instability built in the atmosphere, but then you have to have something that comes along and forces the storm. And that would be, of course, a dry line and a cold front. Now, if you want to know the difference between those, we'll have that coming up in a couple of weeks on the next Learning with Lindsey. All right, now Here it is on the radar, and this is what I'm talking about. A very long, skinny line of thunderstorms. You can get showers that linger after, but the severe threat is only just with this initial line, and you get a lot of wind threat. They'll be continuing to push through the area, and you can get those bowing out segments that we just talked about, how those winds kind of rotate and add to that center of the bow segment. And when you get a squall line, especially along a cold front, that's where tornadoes can be the most damaging. So you get this southerly winds ahead of the cold front, northerly winds behind the cold front, and where those two meet, you're getting opposite winds, and they'll quickly spin up again really quickly. Not a huge threat, and it's going to be typically a weak setup for tornadoes, but you can get them. And then you can see it here on the just a picture of the squall lines. You get this line, and you can see where the clouds kind of form ahead of it. It's a shelf cloud, not a wall cloud. Wall clouds are associated with tornadoes. Shelf cloud is just that initial leading gust front of the storm. And it can look scary, and a lot of people, will see that and think that it's a knack of severe weather, and it's not quite there. Now we're switching over to supercells, and I believe most people know what this one is. You get those isolated storms, and those have the power to really ramp up. They are the most dangerous type of thunderstorm and characterized by a rotating updraft, and this is called a mesocyclone, which I'll break that down again on a different Learning with Lindsey. Right now we're just going over the types and the severity of these storms, and they're highly organized. So what you get, especially, you want them in a warm sector, so ahead of a cold front, but behind this warm front, you get a lot of instability, a lot of moisture and warm air, and you need all of that to produce a supercell. You get these tall thunderstorms and a rotating updraft, and that's of course what produces the tornado, and they are most likely to cause tornadoes, and they are the only ones that will cause EF4, EF5 tornadoes, and they can last for hundreds of miles. So very damaging, very violent storms. This is one that I myself witnessed at my very first job out of college, and it was out in Kansas and Oklahoma area. We had storms moving in. Now, this is kind of fun because it's two different storm setups in one. What we have here, satellite loop of a supercell, and it looked like this. Its signature shape is this hook echo, and it looks like kind of a semicolon. Now you've got the rest of the storm leading edge, and you've got a lot of rain, maybe even some hail up in here, and then you have the rotating updraft towards the southern and southwestern part of the storm, and right in the center of where that little hook is formed, and again you can see it right there, perfect textbook image of this, is where the tornado drops. And you can even see it on velocity where the winds are meeting. The green, light green winds and those red winds are rotating around it. So that is what it looks like on radar and velocity. This is what it looks like on satellite. It was, again, the textbook image of this supercell as it moves in. The insane thing that happened with this. Okay, so it happens again ahead of a cold front. Now what happens along the cold front is you get those squall lines. So this line of clouds, which is actually line of storms, is a squall line. That squall line comes through and completely wiped out that tornado. And it was a very destructive EF4 tornado that moved through that very small town in Oklahoma. So squall line comes in, wipes it out because you get more of a straight line wind threat, completely wipes out the rotating updraft, and it also brings that colder air, which then also cannot produce those thunderstorms because you're not getting that warm air on the inside of it. All right, now here is another tornado that was also out in Kansas in 2025. So this is a different image. We've got the same radar, the hook echo, your tornado is right in there, but on this image is the correlation coefficient. That's what we see, dropping a debris ball, which is how we can see that there is debris from the ground being thrown up, and the radar can pick up on that. So this little dot right there in the center, that is the debris ball, and that means that there is a tornado on the ground, and we can see that just on radar. We don't need footage from the on the ground, although we did get it, and it shows a lot of dust and debris and, even chairs, all kinds of stuff being thrown up, and the radar catches that. And then here was the footage of the actual tornado on the ground. You can see it where the edge right here and then the other edge. So supercells, isolated storms, and they are incredibly violent storms. We don't want to see these. These are most likely to produce those long-lived and very strong tornadoes. You're looking at EF3, EF4, and EF5, and they'll also be very likely to produce large hail because you get a very tall overshooting top. They could be, again, the most insanely dangerous storms. What you also get with this is as the storm collapses on itself, downburst winds, which we'll explain about as well in just a moment. But downburst winds, we've seen that happen. The entire storm collapses and then it goes outward in all directions, typically 2 to 5 miles per hour, or miles in all directions. All right, now we have mesoscale convective systems, and it's more of a collection of thunderstorms, still very strong, but a little bit different than a squall line. You get a cluster of storms that just feed off of one another, and they're thicker than a squall line would be, also producing a very damaging wind threat as well. So you can see where that bow out is, and then you have these the rotation in here and to the south, and they completely just re-enhance the wind threat there in the center. But with an MCS on the southern edge where the winds are rotating back into the center of the storm, you could also get a little bit of a tornado threat as well. So all modes of severe weather, of course, are threatening, dangerous. You always want to watch out for them. They also produce insane amount of rain, precip that falls. You get a lot of training storms with these. Flash flooding becomes a major risk, and flash flooding is definitely a dangerous threat for the area. And you also get those brief spin up tornadoes because how the bow echo, especially, you get those rotating winds just on the outer edge of the bow echo that feeds more winds into it. All right, now I said I'd talk about those downburst winds. Here we go. This begins with thunderstorm that I already talked about, the supercell. You have those tall thunderstorms, a tall structure, and then during the decay stage, so when it doesn't really have enough to really lift that updraft and continue to lift that updraft and lift all the hail that takes to hold the updraft up in the air, it starts to collapse on itself. And when it does that, it all falls, the hail and all the raindrops all fall, and at such a speed and such a strength that it will just rush out when it hits the surface. And it is a really cool sight, honestly. This is what a downburst or a microburst looks like. There's a little bit of a difference, but a microburst is more so for an isolated storm versus a downburst can affect a wider range or a wider area. But this is what it looks like, a wet microburst, typically in a thunderstorm. Thunderstorm's collapsing on itself. You actually get to see where the winds and all of this is falling. So here it is, just a time lapse of a microburst. You have all this hail, rain, and winds that just start to fall as like a ball towards the surface. So here it is actually hitting the surface. And then even here, you can see that line that's rushing out in all directions. So microbursts are incredible to watch, especially from a distance. It's hard to see on radar, but you do get to see a velocity, which we actually saw on another severe day earlier in the severe season. So it was last week, we saw microbursts that came down from thunderstorms, and you can see it just by looking at the velocity signature. It's not quite rotating, but you have this shoom, and it just goes out in all directions. It's pretty fascinating to watch. Now, with these microbursts, downbursts, you still get those damaging winds. You can get very brief moments of 60 to 70 mile per hour winds, even stronger depending on how strong that thunderstorm is. So can cause the same amount of damage that's equivalent to an EF0 or an EF1. Typically, it can be warned, but again, it's hard to really see these on radar. What we know is that they'll happen from a collapsing storm. So you can warn people, especially 6 to 12 hours out, more in a shorter window time frame, and then due to the severity of the straight line winds, thunderstorm warnings are likely issued for these, and I've definitely seen that happen, and they can be brief but very, very damaging, and you can't rule out any wind threat. All right, so that was just a quick little run through of all of the storms that you could potentially see through this severe weather season. But if you want to know more, you can join us on next Wednesday on the Weather Lounge for the Learning with Lindsey segment. And we're going to be talking more just about If you have any questions, you can email them in, but more about the science of what happens, why weather happens, and all kinds of stuff, especially when we have, we progress into the severe weather season, things that come up and events that happen. I'll be breaking down the science behind why it happened, what threats it caused, and why on the next Learning with Lindsey.